topics in such a way that only those which can be asked as questions and only those points which previous patterns were exhibiting, that points only will be picked up and we will be using it as a classification system. The entire list of topics in science and tech, we'll be looking at them as a classification system. What do you mean by this classification system? If I categorize the entire set of science and tech questions, the previous year questions, they'll broadly fall under certain categories. Okay. And within those categories, the entire last year events, I'll put them under those categories. And even within those categories, there is a core point which most of us might get confused with. Okay? We will pick up that point and we will see the logic behind it. So I tried to create something like this very quickly. This is a HTML coded version. I'll forward it. You can download it from the group as well. But this is a quick one pager for the entire science and tech. A quick one pager where you can classify everything. I'll tell you what the classification is. So, if you take a look at the space sector and divide the entire previous year questions into two different phases. In the first phase, you will notice that UPSC was just focusing on facts. Eventually, from 2017 onwards, you are now witnessing a combination of phase 1 and the phase 2 thinking is memory plus application. So you just need to know the fact in the initial years. Say, for example, from 2002, roughly around 2015. From 2015 to 2018-19, I would say it's a combination of memory and application. But now it is about the mechanism also. The stage 3 is about the evolved version of question designs where you need to know the mechanism, the principle as well as the mechanism in science and tech. So broadly speaking, if you see a question, you have to understand what is the basis of the classification of that technology, how does it work, where can I use it. This is the broad 3 categories of your entire list of important points that we picked up from last year. So, say there are many points like this. Brown dwarfs, super earth, extreme nuclear transients, spiral galaxy, solar flares, space debris, Earth's polar orbit. These are all simple definition based classification. What is that? Basic funda, if you know, that's more than enough, because the practical utility of this research is very less, because UPSC won't expect you to know in depth of the astrophysics part. Where UPSC will be more interested is all the space missions and the areas which can impact India. The space missions of, let's say, Europe, Japan, NASA, and all the missions where India can Yeah. So, like we were discussing, the most easiest format of the questions in the exam you can look at from current affairs is this classification, basic definition part. So, in the last 1 year, if you take the Hindu or the Indian Express or any other science-based articles, I classified them into these three categories. Any random definitions from the space and astronomy, that is one. The missions, so when you are mapping them to a identity, so they're trying to solve one specific problem in the domain of astrophysics. Each mission is trying to do the same thing, and you just need to know what that purpose is. Then you have some important scientific terms. So just in case if I missed any important terminology, I made sure that I went through the other magazines as well and clubbed all of them and put them under this. So beyond these terminologies, I don't think there's much, at least in the first category of definition based random terminology. This is straightforward, point number one. And in fact, if you take a look at these missions can again be studied in depth as a problem solution format. Second category is mechanism. So again in this mechanism, four broad categories you should understand. Which four kind of mechanisms can be asked as a question? First is space physics, some terminology there. Then technologies. What is the logic? On what basis are they working? That part you should know. Especially this proton exchange membrane fuel cell. How many of you know the difference between a fuel cell and a battery? What is the fundamental difference between a fuel cell and a battery? Sorry? Now, what is the core problem that a fuel cell is solving and a battery is solving? In terms of technology, are they both the same thing? A fuel cell can generate electricity. A battery cannot. It will just store. That is the basic difference. So both those technologies are different in the problem that they are addressing. In that, this latest technology, proton exchange membrane cell, this is a latest evolution in terms of the efficiency. It is almost 30% more efficient than the usual fuel cells because of this technology. That's the only problem that it is addressing, and if you know till that extent, it is enough. And graphene, etc., that these points we can study in detail. Okay. Apart from this, one last category is application. Where can you apply these technologies in terms of the outer space? What capability we will have, to what extent in comparison with the other nations? Then the digital infrastructure. Now when you're talking about the topic of infrastructure in GS3, you usually talk about infra in two different dimensions. Soft infra, or sorry, the physical infra and the digital infra. Okay, when you're using the same logic in GS2 IR, you're talking about soft power infra. This is the terminology used for the para-diplomatic channels. Namely, let's say for example, you have a body of scientists discussing with each other on a specific international issue. So they're talking about the technological feasibility and technology transfer. So let's say for example, Vishwaguru ambition is there, right, for India. In that context, you can hear this word soft power infrastructure. The institutions that will further the soft power agenda of a country. So this part is for mains, this part is for prelims. Within that, digital infra is necessary for Digital India campaign. Now if you read the Digital India campaign, There are 9 pillars of Digital India campaign. In each of these pillars, any latest tech development that will become important. Okay, in the order of priority, this will be given the first importance. Then you will have other areas like governance and society, international collaborations. These are less important for your prelims exam. This part is more important for your mains exam. Okay, it can be asked, but a mere mention. But given the vast syllabus we have and the wide variety of topics we have, you are less likely to see this kind of questions in the space sector. So these are the 3 broad categories that you can expect questions. And like I told you, this file that I will be forwarding for you, I don't know if you can see it, it's too small, I guess. Is it visible? Okay. You can see, right? I divided the entire category of news articles into 7 different layers, and I created one file. You can just access it through your mobile as well. Just have to download it. There is a HTML file. You can just use it for a quick revision. In fact, if you can write small snippets or take one pager while studying itself, if you're writing, the problem will be solved within the class itself. So you will be getting the file, but additionally, I would prefer for the next 20 minutes, we will focus on how questions can be asked. What is the technology? Are you ready? Please take down your copies and start writing one by one. I'll explain the logic there itself and how question can be asked. Let's start. Now, like I told you, there are multiple topics here. Each of them are categorized into what is it basically about, what is the definition, what is the object we are discussing. For example, cryogenic engine. What is cryogenic engine? That much is enough. And what are the traps that UPSC can lay for us? We are establishing that here. Then you're talking about, let's say, function. What specific problem is this technology addressing? That can be second category of questions. Then, if you are talking about various orbits, because we are talking about space, right? In the context of the latest news items, why are these orbits discussed? What specific problem is this discussion going to solve for us? Next is missions, like I told you. Everything in science and technology should be studied through a problem solution format. It can be a mission, it can be a definition, it can be an orbit, or whatever random news items which are relevant for India. All of them should be viewed through a lens of a problem and a solution format. Okay. This is application part, and finally a collection of all the traps that UPSC can lay for us. For example, let's start with the NISAR NASA satellite, synthetic aperture radar. What is the meaning of this? Basically, whenever you are placing a satellite in an orbit, they are usually placed in a sun-synchronous orbit. Why? Light. Constant light presence will be there. So better clarity, basically. Imagine the vision is blocked because of clouds. So to solve that problem, we will be using this. That's all you need to know. Don't go into the depth of the functioning, etc. When you're talking about L band and S band, it refers to the range and the frequency that a satellite can operate and the increased efficiency and coverage of a certain area. So this is a imaging satellite. Okay. What are the illusions that you can have? If UPSC says that this synthetic aperture radar is a optical satellite, obviously you didn't understand the very purpose of it. Very basic funda. So that is the first thing that you can go wrong in. What is the difference between L band and S band? You need to know. Like I told you, spectral imaging, for example, there is a concept called spectral imaging. Again, I won't complicate things for you. I'll tell you in a very simple language that you can understand. If a satellite is looking at things on Earth, spectral imaging is about using a certain frequency and figuring out what it is. For example, a specific color will have a certain frequency, right? Let's say if the satellite is looking at vegetation, it will have one frequency. If it is looking at soil, it is having another frequency. Depending on the topic that is, depending on the topography, they will represent the entire topography in various frequencies in different colors. The better the clarity, the clearer the image. So when you're talking about the S band as well as L band, you will notice that L band is used for vegetation and S band is used for soil moisture. This much you remember and move on, not necessary to cover beyond this. Next up, Gaganyaan mission. What is Gaganyaan mission? As the name indicates, what is Gaganyaan? Yan means travel. Gagan means first crewed orbital spaceflight program. Why do you want to send astronauts into the space? Why is it a strategic advantage for us? Yes. What exactly? Why do you want to go into space? More than anything, the long-term objective of this is to explore the possibility of making outer space habitable for humans. And the first step in that direction is Gaganyaan. India is using its heaviest rocket till date, and the launch vehicle is called Mk3. Launch vehicle Mark 3. So if you see the word Mk3, it is a very heavy duty engine which is carrying that rocket and the payload, and it will have the ability to take to a very long distance too. Okay. Now, when you're talking about orbits, let's say this is Earth. Like we discussed the other day, you have the low Earth orbit, you have the mid Earth orbit, then you have the geostationary or geosynchronous orbit, where you are placing the satellite at a height of 36,500 kilometers. When you are putting a satellite in low Earth orbit, what will be the satellite doing? Like, most likely what will it do? Communication. Let's say you're trying to let's say USA is here, India is here. Then is it a good place to communicate? Satellite. Imaging, etc. Remote sensing. And then imaging. These two problems can be solved if you're putting a satellite in the low Earth orbit. Then what about the middle Earth? Mostly a relay of satellites where navigation problems can be dealt. You can put it here or even there also. Communication can be dealt with using this highest. If you want to cover a very large area, it's better to put them in that region. All the space observatories, let's say for example, you place it in a different point in the space altogether, namely the Lagrange points. What exact problem? See, I'm always talking about problem solution because you have to remember it like that. what exact problem will be solved if you are putting an object in Lagrange point? Let's say if the objective of Aditya mission is to observe sun and you are saying that I will put it in a Lagrange point, what problem are we solving? What is a Lagrange point? Stable point. What do you mean by stable? The effect of gravity is cancelling. Okay. By putting them here, what exactly are we getting? Exactly. So there is no obstruction and visibility, line of sight. So if the satellite is now, if you are putting a satellite in Lagrange point, but you're not equipping it with the necessary equipment to look at the outer space, is there any use? Here is where you need to know the importance of electromagnetic radiation, electromagnetic spectrum, the entire electromagnetic spectrum. What is electromagnetic spectrum? Yes, we have discussed this many times, but again I am asking. Take a look at this. Now, if I say that a certain take a look at this electromagnetic spectrum. If I, are you able to see this? Sorry? Yeah. Now, when you're talking about a X-ray telescope, what is the meaning of that? If a telescope is called an X-ray telescope, or let's say infrared telescope, what is the meaning of that? Okay, what is the implication of that? Let's say if a certain telescope is working and it has the X-ray telescope, what is the implication of that word? It has the ability to detect X-rays in outer space. Why are we looking for X-rays? Take a look at the frequency here. Which one has more frequency? Gamma, X-ray, ultraviolet, visible. Where are we? In the spectrum. 400 to 700 nanometer range. If you detect gamma rays, what will happen? If you are in the range of gamma rays, what will happen? That will be the last thing you will be detecting in your life. X-rays also, most likely that will be the last thing you will be detecting in your life, provided it is not controlled. If that is the case, if hospitals are exposing us to X-rays, then it should essentially kill us. But that's not happening. What is the controlled environment there? So, a mere exposure to a specific energy level doesn't necessarily mean that the entire object will be dismantled or will be destroyed. The nature of that energy and the impact it will have and the conditions under which we can control that energy. This is an area of research for a lot of our scientists. Okay. So whenever you get questions on satellites, missions, etc., they'll either be trying to know how to manifest this energy and use it for our benefit, or what is the nature of that energy. Because ultimately everything in this world and universe is about energy. And what is the law of energy? Energy can neither be created nor be destroyed. It can only change its form. Based on this universal law, can we leverage that universal law? That's what we are all interested in. Why are we fighting today near the Strait of Hormuz? What is so important about that Strait of Hormuz today? Energy. Imagine suddenly we have a new technology where oil is no longer necessary. Do you really think Trump will be fighting that war? Imagine at the click of a button you can download electricity. Sounds like science fiction, right? Maybe if you can do that, you think the world will be the same place? No, right? The research in this direction is definitely necessary. You cannot deny the possibility of the science expanding its horizons from where it is today. Space research and the missions therein all have a single funda. That is, what is energy? How is it? What are the various forms of energy? What do we do with it? That's all they care about. Once you have a control over the knowledge of that energy, we can do something about it later. Alright. So, understanding the spectrum: radio, microwave, infrared, visible, ultraviolet, X-ray, gamma ray. Now, a quick question. Our 5G technology is in which range? Here, in the spectrum. Here? 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 Infrared? Micro? Radio? There is nothing left here. It must be something in this. What is it? Okay. What is the best possible bet you can take for communication? Least possible technology. I'm not talking about efficiency. In which wavelength can you expect communication safely without harming humans? Radio. The All India radio that you listen to is coming from this, right? Your 2G, 3G, the slow, I don't know how many of you even know those mobiles, the 2G, 3G mobiles, later 4G and then now 5G. What is this generation? 4G, 5G, what do you mean by this LT, long-term evolution? What are these? Speed. Which one is speeder? 4G or 5G? Why? When you say it is quick, what do you mean by that? There is no latency. What do you mean by latency? Latency means delay. No latency means no delay. No delay in comparison with what? Previous versions. How are you able to facilitate faster download speeds? I'll give you an analogy of a postman. I gave this analogy previously also. I'm repeating it once again for the freshers who are here. Let's say a postman gets a small packet of energy from one person, and that postman is giving a parcel to the next nearest postman so that you can deliver it across. If the distance between them is very high, you will need multiple postmen, right? It so happens that our earliest communication devices, like our early mobile phones, were dependent on low frequency radio signals. So the clarity was not good. If you want to take a small packet of energy across a very long distance, you are more likely to lose clarity. But what if I want a very high definition image to be delivered at a very fast pace? What will you need? You will need many such postmen. So you can't expect a single guy to carry a heavy load and run for a very long distance. So he can run for a short distance before he is tired and pass it on to the next person. That's how high definition images in the present technological version in 5G, you're able to download those WhatsApp images even when they are 40 GB, 50 GB. They're actually sending, 40 MB, 50 MB files, one single image. How are they able to do it? It is because of this technology. These postmen in our modern day language are called transponders. And instead of having one tower like we used to have in the previous days, now you have many small transponders which are passing on this energy packets through waves. Okay, so that's how we are getting the quick internet speeds. So the downside of this is it requires huge upfront investment cost. Previously, the frequency in which this mobile phones were working, because they were traveling over a long distance. If you are traveling over a long distance, you need to conserve your energy. If you are putting low energy, obviously you are optimizing it for traveling the distance but not for carrying heavy weight. So radio waves had bare minimum communication, no speed, no clarity. Once we started moving towards the 5G, we decided that we will have to bring in more energy to the table, and that's why from radio we moved towards microwave. I remember discussing this previously also, but nevertheless I'm doing it again now. When you're talking about microwave, it is not the same microwave oven. In microwave oven, you are trying to concentrate all that energy on a single point where you're trying to heat up the water molecule in the food. That water molecule gets agitated and heats up the food from within. That is how microwave works. This is not the same microwave in our pocket. If you are actually carrying the same microwave in our pocket, you can imagine what can happen, right? So it's not the same. So these are the various technologies and the frequencies that you need to know in electromagnetic spectrum. Understanding this electromagnetic spectrum can help you figure out the purpose of telescopes, communication technology, what are the various implications of frequency rise, and what is the difference in amplitude and frequency. Just to clarify, if you see, they're moving, if you can see here, the space between this is very low. So you can say frequency is very high. There is this formula. How many of you know this? Or if you are from the science background and if you know this, fine, otherwise ignore. If you want to simplify this, energy's law is such that you can't have a postman carrying a very heavy load and also expect him to run at a very jet speed. You can only have one. Either ask him to go slow, carry a heavy load, or go fast, carry this load for a short distance. You can't have both. This is how I want you to understand this law. Clear? Now when you are studying for topics on this mission, you will come across various energy frequencies, and the telescope names also will signify what they are trying to observe. So always look back at the electromagnetic spectrum. Clear? Now, so what are the some of the points for Gaganyaan mission? Is it already sent? No, it is yet to be sent. What is the speciality of this? First mission where you are trying to put people in outer space. It is on MK3 GSLV Mark 3, which is the India's heaviest rocket till date. Is India the first one? No. That's all you need to know. Don't have to mug up fourth nation, second nation, third nation. Just know that India is not the first one to do it. Next up, Aditya L1 mission. We previously also saw this Aditya L1 mission in other science and tech classes. What is the purpose of this Aditya mission? Just to observe sun without any obstruction. Two different concepts you need to know here: coronal mass ejection and solar flares. What is the difference between these two? What causes aurora borealis? Is it the sun flares or the coronal mass ejections? Yes. One second. I'll show you the image here also. Take a look at this. Yes. Take a look at this. You have the sun's surface like this, and then you have the chromosphere, corona, and these are the outer layers. Now, what happens is Earth will have its own magnetic field, which will deflect all this external radiations. What is solar wind? A continuous stream of electricity charged gas that is propelled away from the sun in all directions. So when that solar wind hits the outer space, they can disrupt the frequency of communication between the satellite center on Earth and the satellites, and can disrupt the entire power grids. You can lose electricity because they will interfere with the existing communication. So this is one thing. But how is solar flare formed? It is not important. Whenever you see the difference between solar flare and coronal mass ejection, that can be a question. Now, here is where I want you to know the same point. Yes, take a look at this. Coronal mass ejection, a huge bubble of gas. Take a look at this image. Erupting from sun over the course of several hours. The maximum point of the solar cycle, there can be 2 or 3 coronal mass ejections. Look at the nature. It is sudden outbursts. When it comes to solar flare, it is an enormous explosion. And this is something that can happen when the magnetic energy that is built around the sun, it doesn't find an outlet. And suddenly there is that buildup of magnetic energy which is released at once. The difference of these definitions can also be asked. Now, what is aurora borealis? How many of you know aurora borealis? Take a look at this. Now, where can you find these auroras? Near the poles. Why are they formed? take a look at this. What causes an aurora? It's a glow. When charged particles from the sun collide with Earth's magnetic field and atmosphere, forming colorful lights. But why are they colliding? What is the issue when other charged particles are entering into Earth's magnetic field? Why are these colors being emitted? Now think for a minute and then answer. What is light? Light is also a form of energy. Why is this released? What is light essentially? It's a flash or a release of sudden release of energy. What is happening here? There is a clash of different frequencies, which is creating a distortion of our vision and emitting that light. That is the reason for finding the aurora colors. But where are you going to find those colors? The colors change based on the gases at different heights in the atmosphere. Now remember, if a question says all the aurora colors are green, you should mark it as wrong. It depends on the gases available at that different heights. And these solar winds which are coming in our direction, they will actually create this auroras in our northern hemisphere. You need to know these points. What are auroras? How are they caused? Because this is a previous year mains question also. You might get a mains pointer from there also. Alright, so let's get back to our discussion. Then last year we saw this respective experiments from ISRO, SpaceX Chandrayaan and Axiom 4. Axiom 4 is the latest edition that you have to focus on. I think these two may or may not be asked, but Axiom 4. It's a private mission. The Axiom 4 mission is a private mission. What is done here? India's Shubhanshu Shukla is the name of the person who was in this first Indian to visit the International Space Station. Why do you want to visit International Space Station? What is the advantage of having a space station outside? How many of you know what is International Space Station? It was under the collaboration of one country which decided not to prolong its collaboration. Any guess? Russia. Okay. So what it is essentially doing is, it is trying to put people in the outer space. Just like how Gaganyaan is also aiming for that. The only coincidence here is, just because the person is an Indian, we might assume that it is a part of Gaganyaan. So what can be the trap? It is not an ISRO mission. First of all, you need to know that. It's a private commercial mission. Okay? It is a private commercial mission, and the person is also a private mission specialist. Is not from the government side. It is not under Gaganyaan, and it is not using NASA's spacecraft. It is using SpaceX, Elon Musk's company's rocket. Now, next one. Here you will have Earth observation constellations, and the reason why we want this Earth observation constellations from the private space is, the objective is twofold. First of all, our agriculture is a major problem because it is not treated like a business. The amount of output one can expect from a given unit of land, depending on the local conditions there, requires sensors on the ground and communicating at scale through satellites to the entire region. So precision agriculture coupled with AI can give massive advantage to farmers, because they will understand what price to expect at what time, and this will improve the farmer's income. So India wants commercial Earth observation satellites in private space, because everything to be produced by the ISRO's missions, it's going to be expensive, and it's also time consuming. We need public-private partnerships for the same reason. Can have defense surveillance and even in urban planning, the same thing. Anyway, we'll move forward. Earth's polar orbit. Again, you are talking about polar orbit and it is not the same as sun synchronous orbit. What is the difference between a sun synchronous orbit and polar orbit? Any idea? I asked you to prepare the basics and come. But why are we looking at poles? Why do you want to observe or move over the poles? It should have a specific reason. What do you mean by sun synchronous? We in sync with what? Earth's, sun's movement. So that we have access to light. Now you have to remember that sun synchronous orbit is one type of polar orbit. When you are in geostationary orbit, when you are moving with the earth just like this, you don't cover the other areas. You are looking at the same point 24/7. Now, when you're looking at the other orbits, you will put them in different. Either they will move in this direction or this direction. So this is the difference in the orbit so that you can observe different points on Earth at different time periods. Okay, that is what I wanted you to know. Cryogenic engine, as the word itself indicates, cryo means something that is cooled down, minus 150 degrees almost. So it will give you the initial thrust, which will be very useful for taking heavy payloads. Sorry, not the initial thrust. After the initial thrust in the outer space, if you want to move farther into the orbit, that is when this cryogenic engine will come into the picture. So let's say if the entire journey of the satellite through this rocket is there up till 36,500 kilometers. In the initial stages, you will get the solid fuel thrust and it will escape the Earth's gravity. And it will be on its autopilot mode for a certain distance. But after this point, if you want even more thrust, that's when the cryogenic engine will come into the picture. So here is where you need to know. When you're talking about cryogenic, the focus is not on temperature. Why are we trying to cool it, by the way? It will also optimize for the space available in the rocket. And you're going for a very long distance. That's the reason. It is efficient. Then the Naik constellation that we discussed the other day and the atomic clock failure, that part we already discussed, right? So that's what we have to focus on. HOPE analog mission. Again, what is this analog mission? You're trying to create the conditions of space here. Where? In Ladakh. Why? Because apparently it is closer to Mars-like terrain. So this is basically a preparatory research for Gaganyaan. What if you have similar conditions in outer space? What will you do? We are trying to create that situations on Earth so that we will learn something new and prepare ourselves and our astronauts for that kind of an environment. So it is not an actual space mission. You have to remember that. You are just trying to recreate that scenario on the Earth's surface here itself. Lunar Module Launch Vehicle. What is the difference between this and LVM-3? Don't get confused between the launch vehicle and this lunar vehicle. So you are trying to launch heavier payloads to the moon. You're trying to send even crewed lunar missions. Like you want Indians to land on moon. So you need heavier payloads. You need to be able to carry these people safely till there. For that specific purpose, and India has a long-standing ambition to have a permanent space in the moon research. Like it wants to mark its authority in the space research, especially in the moon area. For that, this will be useful. So, like this, I created some important terms where you just have to read the context and also the immediate traps that you can have. What all important news items that can be asked in this year's exam, mainly Axiom 4, I've already discussed them. Rest all are miscellaneous terms, and I don't think they'll be asked in the exam, but nevertheless, if everybody is reading, you should also read. And what possible mistakes you are trying to make in that area, I've placed it here as a quick revision. You go through these traps, most of the topics will be covered just like this. Don't spend too much time. I'll be posting the link on the group. You can follow that. Okay, that's it for the day. And this much is enough in space sector. There are not much developments in the last couple of years in the space sector. So I'm not expecting any big question. So either you will get a telescope based question. Let's say if they want to ask James Webb telescope again, which is in news since 2-3 years. That is one area where you can expect. Again, you just read whatever is given here. That will be enough. Okay, nothing beyond this. I think this will be enough for entire prelims and low utility for this year in the terms of space. But again, UPSC can go in either direction. So know the basics, know this much. That's all. If everybody is preparing this much, you should also prepare. That's the reason I'm giving this topic. All right. Thank you.